Hi all, welcome to the video. In this video, we are going to talk about node pool auto creation, that is NAP also, node pool auto provisioning, how it works in GKE, what are the options we have. So basically, node pool auto creation is an infrastructure auto scaling mechanism that lets GKE create new node pools in your cluster and that meet the requirements of your workload. So if you want like GKE create new node pools according to your configuration or machine types which you require to run your workloads. So you can enable node pool auto creation. So in this, GK will manage your auto created node pools. It will perform tasks like updating node pool metadata, creating or deleting nodes inside the node pool, and even it can delete the entire node pool when it is no longer needed. And it is an extension of GK cluster autoscaler. So we have already discussed autoscaler in our last part or in the last video. You can check out that video if you don't know how that works. And basically, cluster autoscaler automatically scales nodes in a individual node pools. So if you are using autoscaler, it can add more nodes in a specific node pool. So it is just an extension of that autoscaler. And node pool auto creation is designed to let GKE automatically scale down or remove empty node pools from your cluster. So if you don't need, it will automatically delete, or if it is not running any resources, so that specific node pool will be deleted from your cluster so that you can save on cost also. And in this we cannot set a minimum number of nodes that every auto created node pool must have, because if you set a minimum number of nodes like greater than zero, and so that can prevent the removal of empty node pools, as we have seen in the cluster autoscaler, in which we can define maximum and minimum number of nodes. But in this, if we try to do this same thing, so our node pool auto creation will not able to delete the empty node pools. Suppose if we define we want a minimum one, so if because of that this node pool auto creation will not able to delete the node pool and it will kept on running. So it will move away from its main purpose like adding or removing node pools and adding or removing nodes. So we will see how it works and I will show you what will happen if you try to do that also. And so how it works, basically you can define your hardware requirements in the, so when you use the compute class, you can use or select the compute class in pods by using a node selector. And now it is a recommended practice or recommended method by Google, because you can centrally define the common node configuration that multiple workloads can use instead of using node selectors or node definitely. You can also use this also, but it is now a recommended option. We will see both of the option in our demo and how to use both of these. There are two methods for the node pool auto creation. First one is workload level, second one is cluster level, and this is one is now recommended one. So for the GK version, if you want to use workload level, you have to use this version, at least this version, or greater than this. And if you are using any old version, so you can use this legacy cluster level also. So what will happen in this, you will use compute class. As we have seen, like there is now option of using compute class. So in this you can use compute classes. And here we have used cluster level node auto provisioning. So we have to enable this node provisioning by in the cluster. I will show you how it will happen. And for the scope, it will only for the selected workloads only. It will enable cluster like node auto provisioning for the entire cluster. And for the node pool creation, only workload that select a compute class. So you have to define a compute class in your like deployment, pods, or anything. And in this, any pending workload can trigger it. So in this, what will happen if any pending workload basically means any deployment pod need a new, suppose there is no resource available in that in your cluster. So any pending workload like deployment pod can create or trigger it. Cluster will start creating a new node pool. Resource, so for the resource limit, it is not required if you are using a workload level, but for the cluster level, you have to define a total number of CPU memory your cluster can use. And for the control granularity, it is fine in per workload. It is very broad. It is for the cluster wide. It is recommended as of now, and it is very for old or legacy clusters. So what will happen in the workload? You will define a compute class, and based on the compute class, the new node pool will be created or new nodes will be added in the specific node pool. In this, you have to enable this specific node pool auto creation at that cluster level. There's an option I will show you, and when you enable it, it will work for the entire cluster. If any workload is in pending state, it will start getting a new node pool, and it is also we have to define the total CPU and memory you can use. So you can define like I want like maximum of 20 CPU and maximum of like 40 GB of memory can be used in my entire cluster, and it will like consist of all the node pools which can use this. That doesn't mean only one node pool can use that specific range. It is for the whole cluster. Now let's move like cluster level resource limit with node auto provisioning, which I am talking about. So when we enable node auto provisioning for entire cluster, you must also configure limits for CPU, memory, GPU, TPU, like how much you want to allocate. And these limit applies to some of all the resources capacity in the cluster, including manually created node pools and the compute classes. So if you are using cluster level resource limit, it will work with compute class also. But if you are using workload level, then this limit will not be applicable. And GK doesn't create new nodes or node pool if the operation would exceed one of those resource limits. So suppose you have defined I want maximum 20 CPU in my whole cluster, and I defined 40 GB of memory in the whole cluster. Now you have already 20 CPU running in your cluster, and memory is still 30 GB. And now if even memory is free, you can add 10 GB of more memory, but there is no space to add, or there is no CPU available to add now. So it will not create any new node pool, or it will not add any new nodes inside the node pool also, because of the resource limit. Even if one of these resource limit will exceed, it will not create or add new node pools or nodes inside a node pool. And these cluster level resource limits are required only if you enable node auto provisioning in the cluster. So if you enable into this in the cluster level, then only these limits are required. In cluster that use version, this specific version, and later you can use node auto pool creation using compute classes without even enabling node auto provisioning. So you don't have to enable this at the cluster level. You can use just the compute classes and use that node auto provisioning without even enabling at a cluster level. And if your cluster meets these requirements, we recommend that you use the only compute classes to configure auto-created node pools. As we have talked about, compute class is the future of this node auto provisioning. For the limitations, so all the limitations which are applied to the cluster autoscaler, which we have already seen in the previous video, it will apply on this auto pool node pool auto creation also. And if your cluster have more than 200 node pools, so you may face some latency during auto scaling. And any resource limit that you set for the cluster when you enable node auto provisioning also apply to node pools that GK create for compute classes, as we have already seen most of these things. And these settings are not applied, like search upgrades, blue green upgrades will not work by compute classes, node integrity and secure boot. And this is the important thing to enable node pool auto creation for a compute class. This version thing you have to remember. So if you are using a version less than 133, this one, so you have to enable that node pool auto creation at the cluster level. But if you are not, if you are using any version greater than this, so this limit will doesn't apply. You can directly use the compute class. So now let's go to console and see how these all things works and how we can use it. So I'm in my console now. Let's click on create cluster. So I'm going to use a standard cluster to show this specific demo to you. So in the cluster basics, I'm going to use my same cluster one. I'm going with the zonal cluster. And for the, let's go to our default pool. So this is the option if you want to click like enable cluster autoscaler, which you have seen in the previous video. You can check out that video if you want to. And if you go to nodes, you can define all the configuration here. So let me change to standard persistent disk. There'll be some quota issue in this free trial. And if you go to automation part, from here you can enable node auto provisioning also. We will see in the like in few minutes how to do this. But if you go back to our cluster basics, as I've told you, let me show you, like we are using this version, target version 133.5. And if we come back to here, and we have defined, we can use, if we are using a version more than this 133.3, we don't have to enable that cluster auto scaling also. We can directly use compute classes, and cluster will automatically add new nodes pools in our cluster. So what we can do, we can just create the cluster, and after that we will create one new cluster in which we will enable cluster auto scaling also. But on this specific part, we will go without cluster auto scaling. So my cluster has been created, and if you go to details also, and let's come down, and if you click on this node auto provisioning, you can see it is as of now disabled. We haven't enabled it as of now. So now let's go to our cloud shell. And let's do some demo in the here also. So what I'm going to do here, if I do ls, I have a deployment.yaml file. In this I'm going to create some like deployment. So let me apply this. This is a very simple deployment. It will create some like an nginx deployment in which it will run two pods. And let me apply this. So if I run kubectl get pods, I can see we have two pods are running successfully. So I have one more file. So if I go to spot pods, so let's go to this and do ls, and if I do cat deploy.yaml, so in this what will happen, I am going to use this same nginx deployment only, but here I am asking there's a toleration. So I want that these pods will be scheduled on a node in which we have a node selector that is true, and this also like operator equals to true and no schedule. So if we in a node we have a this specific node selector with that is like GKE spot equals to true, then these pods are going to schedule on those nodes. So let me run this file also, and I will show you what will happen now. So I have created this, and if I do kubectl get pods, and we can say it will be remaining pending state only because we haven't enabled the cluster auto like node auto provisioning, or we can say cluster node auto provisioner. So it will remain in pending state only. It is because we haven't enabled the cluster node auto provisioning, and if we come here also, we will see it will not adding any new nodes. It will remain in pending state because if you want that it will add these new nodes, we have to enable the cluster node auto provisioning, or you can use the compute classes. So now let's go with the compute classes. Let me do cd and do ls, and if you go to cd compute classes, I have a directory for this, and here I have some created something like if I go with cat compute classes -n4.yaml. So in this I have created a compute class, and in this I have defined like kind is compute class, metadata is n4, and in this I have like defined priority defaults also, like location wise I want that my nodes must be created in US Central 1B, and auto like this is very important thing, node pool auto creation enable true. So what will happen, it will create the new node pool. If you don't put this enable true, it will not do anything until you enable cluster node auto provisioning also. And the priorities, I have defined two priorities. If n4 is not available, please go with n2. Like there is a machine family, and when like unsatisfiable, you don't do not scale up, wait for until the machine is available. So now let's run this. So basically, it is not a compute class video. It is not auto provisioning video. I will cover compute classes later on. So let's create this -n4.yaml. So it has been created. Now, if I run compute class, we can see we have created a compute class. Now, if I do ls, so now I am going to do cat deploy.yaml. In this, you can see this is a simple deployment. This is a name hello web and one replica only, but here I have defined a node selector. I want that this specific pods or deployment must run on a compute class which is using n4. So as you remember, I have created a compute class also. Let me show you that also once. So this is my compute class. So basically I want that this deployment must run on a node in which we have this kind of label like cloud.google.com compute class equals to n4. So I'm just asking to run these deployment on a compute class that is using n4. So it will come to this compute class that is my n4 compute class, and it will see what this compute class want. So if I do compute class -n4.yaml, so basically it is going to create a like node pool in this specific location US Central 1B, and it will try to match this family. It will first try to go with n4. If n4 is not available, it will go with n2. So now let's run this kubectl apply -f deploy.yaml, and you can see it is started creating the node pool n4. As we have defined, we want n4. If n4 is not available, go with n2 machine type family. It is creating n4. Even we have not enabled the cluster auto scaling at the cluster level. You can see it is creating n4 standard 2, and if we come here in some time, as of now the pod must be in get pods, it must be in pending state only. So you can see hello web, this is our deployment name also, hello web. It is in pending state only. And the other pod, that is Nginx one, which in which we have used spot VMs, it is also in pending state. It will not run because we are not using compute classes in that. We are using just node selector. That's why it is not working. So, but in here we are using compute classes, so it is working without even enabling the node auto provisioning also. So we can see it is creating a node pool. Like this, you can do use compute classes also. Basically, compute classes is a much more advanced option. You can define anything you want. So if I am one more compute classes, if I go with this cat compute class.yaml, so here I have defined the even though you can define a machine type also. Like I want E2 high CPU too. Like this also you can define, like you want a specific machine type for a specific machine, like your workload, you can define that also. So this is the more advanced option you can use. Compute classes, you can define make what machine types allowed in your organization, all that. As I've already told you, we are going to cover compute classes in future videos. I'm just covering node auto scaling for this video specifically. After waiting for some time, you can see that my node has been created. Even if I go to my compute engine and let's see which machine type it is using. And if we come down and we can see the machine type also somewhere here, only machine type is N4 standard 2 that we have defined. So it is using a N4 machine type. So now let's run kubectl get pods to see whether our pod is running or not. So we can see pod is running, hello web is running. We can see our node pool has been created, and I want to show you something all here also. Wait, it's go. So you can see in the auto scaling part, you can see 0 to 1000 node. So 0 means it can scale back to one node to 0, like when there is no more like resource or workloads are running on this specific nodes, or there is no more requirement of this node, it can scale back and it can go up to 1000 nodes. And if I come back here and if I deleted my deployment also, let me get deploy, and this is my deployment. And if I delete this, so what will happen? It will sometime it will scale back, or we can say delete this node pool also. Now it has been deleted. We have to wait for some time. Basically, it will delete only because there is no more traffic on this specific node. So it is going to take some time, about I think 10 to 15 minutes to delete this node pool once the traffic is gone or it is no more being used. So instead of waiting, we can do just delete this cluster and create a new cluster so that we can test more things, and we can enable node auto provisioning also if we are using an old version. So I will just click on delete cluster and just click on delete, and let's wait. So now I'm going to create a new cluster once again. Now I will use a old version so that we can see more things. And let's go to cluster one and going with the Jono cluster only this time also. And in this I am going to use like 130. This version is good for our PPT, as if you see 133.3 for workload level, and for the below level, if you want to enable as a cluster level, you can go below on this version. So this version is great for us. And for the default rule, I am going to go with two nodes only. And then in this I'm okay with standard persistent disk, and 70 GB is enough. And now let's create a cluster. I will enable cluster auto scaling after creating the cluster so that we can see more options. Now let's click on create cluster. We can do now. Let me create one more once again compute class. So if I do, let me create kubectl apply -f compute class n4.yaml, and if after that I will create this deploy.yaml kubectl apply -f deploy.yaml. And if I run kubectl get pods, this time I think it will not going to create the new node pool because we are using a cluster in which we are using old version, and also we have not enabled the cluster auto like node auto provisioning. And if we come here in the nodes section also, and if we just refresh the page also, it is not going to do anything this time. So if we want that it will do anything, we have to enable the cluster auto scaling. So to enable the cluster auto scaling, you have two options, like you can go with the command line also, or you can enable via the console also. So I'm going to enable via console, and I'm going to come here in the automation part. You can click on node auto provisioning, and just click on this enable node auto provisioning. So now you have to define the limits, the maximum and minimum limits. So I want like minimum at least 2 CPU in my whole cluster, and maximum CPU it can use 10 CPU. And for the memory part, I'm okay with minimum 2 memory GB of memory, and maximum it can go up to 16 GB of memory in the whole cluster. So it will include all the nodes which are running in the cluster, all the node pools basically. So if I'm running 5 node pools, so or like it cannot go beyond 10 CPU in the whole 5 node pools, and for the memory it will not go beyond 16 GB. You can define any specific service account also if you want to use. I'm okay with compute default service account. You can define access scopes also. You can define node pool upgrade strategy also. I am going with surge upgrade only. And you can define the custom like node pool locations if you want to enable create node pools any specific location. I'm okay with that. Like custom, it can choose because it is a zonal custom. Doesn't it will not create much issue for me. And after that, for the auto scaling profile, I'm going with optimized utilization so that it can quickly delete and create the new nodes. If I go with balance one, it will take up to 15 minutes, but with the optimized utilization, it can do all the things like adding or removing nodes in 5 to 6 minutes. I have covered this optimized utilization in my previous video. You can check this out. Let me click on save changes. So basically, it is going to take up to 10 to 15 minutes because it is a cluster level change. So let's wait for 10 to 15 minutes and then we come back. So our cluster like auto scaling has been enabled. So like now what we are going to do, I have a, as I've shown in the start of the video also, I have a deployment.yaml file. In this I'm using 2 replicas and this is my deployment name. So I'm going to run this. Let me run kubectl apply -f deploy.yaml, and after that I'm going to increase that pod count or replicas count. So scaled deployment hyphen and replicas, I'm going to go with 8 replicas, and after that let me run kubectl get pods, and we can see some are in pending state. So now let's see whether our cluster autoscaler will add no new node pools or not. So we can see as soon as it is in pending state, it will start adding new node pools also. You can see we have done anything. It is just started and added a new node pool E2 standard 2. And if we come back here in some time, it will show here also that nodes. Last time it doesn't done anything because we haven't enabled the node autoscaler, but this time it will work. As we can see, it has added the pod also node also, and let's see when it will show here. It will take some time to reflect in that CLI. Let's wait for till then. So we can see in this in the node pool it is showing it has been added. Now let's see kubectl get nodes. We can see third node has been added, and if you run kubectl get pods this time, and we will see that all are running in the running state. So like this, if you have some pods which are in pending state, and if you enable the autoscaler and you are running a specific version, and so that it will work, basically it will just increase the node pool count. But if you want to just use the compute classes and you don't want to use this function, like if there are some pending pods and it will not create that new node pools, then you can go with above version. But if you want to use this specific thing, you have to use some specific version and enable the node pool auto scaling also at the cluster level. Now the next part we are going to do ls. Let's go to compute classes and we will see ls get compute class hyphen info.yaml. So in this we are want to use we are going to use this same file. Let me apply this file. We have seen previously also how this file works. Apply hyphen f compute hyphen dot for YAML. So we have created a compute class. Now if I do ls and if I do cat deploy.yaml, so this specific deployment will going to use this specific compute class. So it will going to create a node pool which we have defined in the in our configuration. Basically N4 or N2 machine type machine family it is going to create. Let me apply this hyphen f deploy.yaml. So that has been created. Now let's see whether it will create the new node pool or not. So what do you think whether it will create or not? There's some chance it can create or not create. It all depends upon the configuration of your cluster. Now let's wait before we finalize anything. Cluster level, I can see it is giving me some error like notification scaling issues. can't scale because of some failing scheduling predicate, and we can also see it will not like scale up because it will exceed resource limits. I think something is happening here. And if you see, we are using total number of 6 CPU and 16 GB of memory. Now let's go inside the cluster. Let's see what is happening here. And if we click on the nodes also, and if we come down, so we can see this specific node. Basically, this one is using about E2 standard 2. So it is using about 8 GB of memory, I think. Yeah, 8 GB of memory. And other two nodes are using 4 GB, 4 GB. And let's go inside this also. And if we come down, it is using 4 GB. The total 16 GB is already being used. And if we come to our details of the cluster and just click on this, and if you see, we have defined maximum of 16 GB memory can be used in our whole cluster. So that is already being used. That's why it is not getting a new node pool. So to fix this, we have two options, whether we can increase the count from there, or if you don't want to increase the maximum count, just you have to do delete the old node pool. So if I do ls and kubectl get deploy, so I'm going to remove this deployment, I think old one that is running fine. So kubectl delete deployment. I will just click on this. So what will happen? It will just have deleted all the pods and my deployment. So now it is only one base pending hello web. So what will happen sometimes if you click on nodes, it will delete this node pool because there is no much traffic or it is not being used anymore. And you can also see it is showing 0 to 1000. So 0 means it can delete to scale down to 0 and delete the node pool. But for this, it is showing off. So it will not touch this default pool because it is manual one, but it can do anything on this specific node pool. Now let's wait for a minute. It will start deleting this and creating our new node pool for our hello web, and which is going to use N4 machine type. So we can see it has started creating a new node pool N4 one, and I think it is also deleting our old one. We can see if we come back here, I can see it is deleting our old one. That is for spot, that is E2 standard 2. Let me refresh it, and we can see it is deleting this and creating this one. So like this, once it will start deleting this, capacity will come back and it will start creating another one on the same time. And if I do kubectl get nodes, and let's see, you can see it is in not ready state, so it is going to be deleted, and this is has been created N4 machine type. And if I do kubectl get pods, we will see our pod is must be in running state. Now let's delete this also, and let's see more things. Delete deployment hello web, so that it can delete N4 also. We don't need this anymore. Now let's do one thing. Let me go to cd spot pods directory. Here we have a deployment.yaml. So in this we have defined like we want to create an nginx deployment. We want two replicas, but these are toleration, or we can say node selector. We can define the node selector also directly, in which I have defined I want GKE spot. I want spot VMs, that is true. And this is the toleration like cloud.google.com GKE spot equals to true. And effect will be no schedule. So if you want like tolerate this toleration, then only your pods can be scheduled on this node, and node selector is also defined. So if I run this kubectl deploy hyphen, the file name is deploy.yaml, so it will create a new node pool. What happened? Okay, let me this apply command, not deploy, sorry. So our ng it has been created. Now let me do kubectl get pods. It must be in pending state because we don't have a spot VM node. You can see both are in pending state. And if we come here, it will not create the new node pool until this node pool has been created, because we have a strict like defined like how much we can use like resources. So if we can see it has started getting a spot node pool, but on the other side it must be deleting this also. We can see it is already been deleted nap n4 one, and it is started creating new one that is for spot VM. And we can see it will show, it will reflect fast here but slow in compute engine, no, in compute Kubernetes engine, we can see it is deleting N4 and creating our standard spot VM node pool. And if we come here and do kubectl get nodes, you can see it is in ready state. Okay, this is an old one. Let's wait for some time. Okay, now it is non-ready and our spot node will be soon available for us. We can see spot is now available, and now if we run kubectl get pods, it must be running state, both the pods. If it didn't continue creating, it will soon be running. That is done. Now what more we can do, if I do cat compute class dot yaml, we can even define the machine type also, like E2 machine, high CPU, and we can define like when unjustifiable, do not scale up until the capacity is available, do not scale up. You don't use any other machine type. I want E2 high CPU 2 only. Like this, you can define machine type also if you want a specific machine type, or in even if you go to like I have a one more, you can define in the pod also. Like I want this specific pod to run on this specific machine type. Let me run this pod also. kubectl apply -f new pod.yaml. So I have defined I want a node selector in this machine family must be E2 and that instance type to be E2 high CPU 2. And if I do kubectl get pod, it must be in pending state because we don't have much capacity. We can say it is pending state. Let me delete this one because we have tested this already. So kubectl delete deploy and then is deployment. It has been deleted. In a minute or two, it will start creating a new node pool in for this specific pod which we have defined. We will get pods, only one is in pending state. Now let's wait for a minute or two. You can see it is started deleting the spot VM node pool and it is started creating a new node pool that is E2 standard 2 that we have defined even our pod cat I think what new pod.yaml that is E2 high CPU 2. So it will create something like this for this our new one where it is you can see E2 high CPU 2. So it is creating a new node pool for this specific node selector. Like this, you can define a node selector also, machine type, and all these things. And even if you can create a compute class also, if we go here, you can define the compute class, same thing. And you can call this compute class in your configuration. So let me show you like this pod test.yaml. In this, I am just calling this compute class. That is test one, which I'm going to create. So you can go with like this step also. So there are multiple options. Better to go with compute class. So you can define which machine type or which machine you want to use instead of defining in the node selector or in the or like in inside your pods like here, like what you want, because it can create issues. Better to go with compute classes. It is more good and helpful. So I have one more file. If I do ls cat resource.yaml, so like this, instead of enabling auto scaling at that cluster level from the console, you can do from that CLI also. So you can define here like what you want, like to seat minimum, all these things. So let me edit it. Resource.yaml. Let's go with 18 of memory, and you can add more things like management, auto repair, true, auto upgrade, shielded instance config, like enable secure boot, enables integrity monitoring. All these things you can enable. Let me run this, and if I run this command, gcloud container cluster update. This is my cluster name, location, enable auto provisioning, and I'm just updating my cluster, and I have to provide the file name, that is resource.yaml. Just click on enter, and it will start uh, updating the cluster, and we can see it has updated the cluster very fast. And if we come here in the details section, and if we click on node auto provisioning, we can see now it must be 18. Before it is 16, now it is 18. Like this you can do all from there also. And one more thing, like if you want to add any manually created node pool, suppose you want to add this manually created node pool into your cluster auto scaling part, so that it can also add or remove nodes from this also. So what we can do, this one more command I will show. what I have to do, let me come here, and if I have to run this command basically. Gcloud container node pools update. You have to define a node pool name, cluster name, location of your node pool or your cluster location, sorry, and enable auto provisioning. If I click on enter, it will give me an error. Let's see what error it is saying. Node pool like invalid argument node pool auto scaling cannot be enabled when auto scaling is disabled. So if you want to enable the node pool auto scaling, so you have to first of all enable the auto scaling also here, because as you know, your cluster can be delete any node pool in which there is no more traffic. So as of now, we have defined like we need two nodes as of now. So it will not work because it cannot delete this default pool. So if you want to enable node auto provisioning on this also, you have to go inside this node pool and click on edit, and after that you have to come down and click on this enable cluster auto scaler, and you can define minimum nodes I want 2 and maximum I want uh, minimum I want 0 and maximum I want 2, and just click on save. You can define anything what you want, but it will automatically be changed once you enable that auto scaling at that node pool level. So it is as of now updating the cluster. Let's wait for a minute or two. So we can see it as updated. Now if we run the command once again, the same command, now run this, and it will start updating the node pool, and it is now working. It is not giving any error, and it has been done. So now if we go back here, we can see it is showing is auto scaling 0 to 2 nodes per zone. Here it is showing 0 to 1000 because it is created automatically, but for this now it is showing 0 to 2 nodes per zone. You can do anything. So now this specific node pool will be handled by our node auto provisioning. If there's no traffic, it can delete this node pool also. Like this, you can do multiple things with that help of this. I think I have covered most of the things. What are the options we have, how we can do it, and let me. You can also disable anytime if you don't want to use node auto scaling. So any nodes which are being managed by your node auto scaling will not be managed by it, and if you re-enable it at later time, you have to again put these node pools back into the node auto scaling part, so that node auto scaler can again manage those specific node pools. So like this is the node pool. If I disable the node auto scaling at the cluster level, it will become a manual node pool. So there's so much of things you can check out. So much of documentation is there for this. You can define according to your organization needs. Just come here and I will just disable this now. If you want to disable, just click on disable. Nothing much you have to do, just save changes. And it is a cluster level change, so it can take about 10 to 15 minutes. So like this, you can use compute like node auto scaling, and you must use compute auto like compute classes. It is a very good feature, and it is a recommended feature also now. And if you are using a specific version which I defined or show in the PPT also, then you don't have to even enable that cluster auto scaling or node auto scaling at the cluster level. You can just use the compute classes. But if you are using a lower version, then you have to enable that cluster auto scaling at the cluster level, and it will not work until you enable that. And that's all from the video. I think I covered most of the parts which I know I try to understand for myself also. If you have any question, suggestion, just comment it down. I will try to help you, and I will drop an email ID. Just drop me an email if you have any questions, suggestions. I will try to help you if I know how I can. Thank you very much. Bye.